Hi everyone, and today we're going to solve this LeetCode daily challenge called maximum level sum of a binary tree. So basically we are given a root of a binary tree and we need to find the smallest level such that the sum of all values of nodes at that level is maximal. So what we can do, for each level we can calculate the sum of all the nodes first. So for level 1 we have sum 2, suppose. For level 2 we have sum 5. For level 3 we have sum 10. For level 4 we have sum 11. For level 5 we have sum 11. For level 6 we have sum -2. So in this case, what is the maximal sum? It is 11. And there are two levels at which this sum is present, level 4 and level 5. So we need to return the smallest level, that is level 4. So in this case, the answer will be 4. So what we can do is that we can do a BFS on this tree. And after doing that BFS, we can find what level is assigned to each node. And that first for each level, we will calculate the sums. And then we can traverse that map and find the smallest level, which is the maximal sum. So BFS will use the queue data structure. So we can start with that, and we can add a root node in that. And while queue is not empty, we can get this node. If the left child of this node is not null, we can add this node to the queue. Similarly, if the right child of this node is not null, we can add this to the queue, and in the end we will calculate some answer by traversing that sum and level map, and we'll return that answer. So now how we will do this? So first of all, we need to know what level is assigned to each node. So for that I will take a map which will map the node to an entity, to the level. And we can take another map which will map level with the sum. Now for the root node, we know that the level of the root node is 1. So for root node I can put level 1. And for the sum, for level 1, the sum will be the value present at the root, something like this. After doing this, when we are talking about the left child, we will update the level first. So we need to find the level of this left child, which will be 1 greater than the parent. So level dot put, and I'm talking about the left child, and what we're going to put, we will get the level of its parent, and we will add 1 to that. So this is how it will work. The similar situation will be for the right child as well. Okay, now what you want to do is we need to calculate the sum of each level. So for sum we will get the level of this left child first, and on this level we need to update the sum. So how we are going to update the sum? We will get the sum for this left sum at this level. Like we are currently on what level? On left child's level. So first I'm going to get the level of the left child using this, and on that level what is the sum up till now that I'm going to fetch using this. So basically we will use get or default method, because if for this level no key is present, then it will return null. So here we can say to return 0 instead of null, and we will add the value of u dot left dot value. Yeah, in this similar case we are going to do for the right child as well. I think this should be clear by now. So with this, in the sum map we will have level comma sum at that level. Now we will keep a variable to track the maximum sum, and we will initialize it with the minimum value possible. Now we will traverse this map, sum map, and this is how we will do it. Sum dot, yeah, and what I'm going to do is, if our max sum, like the sum is greater than the max sum, the max sum will be updated to this value, and our answer will be updated with the level, something like this. Okay, there is some okay, empty spelling is wrong. Yeah, so it looks like it's working. Like I'm doing a full screen so you can see the code, how it works. We are doing basic DFS, and for each level we are just calculating the sum of nodes at that level, and finally using this we will find the smallest level with the maximal sum. Now I can submit this problem. Yeah, so the time complexity will be O of v plus e, since it's BFS. So since there are n vertices, if there are n nodes, there are n vertices and n minus 1 edges. Since it's a tree, so 2n minus 1. So O of n is the time complexity of this solution. So thank you for watching this video. I hope you liked it, and please share and subscribe.